So this video is how to run the GOF test if you do not have the calculator command, GOF squared chi-squared test. So if you go to test and you have this command, D chi-squared GOF test, then you don't need to watch this video. But if you don't have that, then you do need to watch it because you have to do this test differently. Okay, so we're going to look at example 1. I filled in the observed and the expected in the other video where we said observed is the counts. Okay, so if you haven't, make sure you read this example first, pause the video, read it. After reading it, we see that we have a sample of 1,000. Okay, so N is 1,000. And we have the counts for each preferences. That's the observed values. So we put them in the observed value. And then to get the expected, how I got the expected again is I take the probability of each one. So the probability of vanilla is 0.025. To get the expected, right, and that's what I guess. You don't have to do this again, you can just put it in the table. But if I wanted to find the expected for the vanilla, I take the 0.25 and I multiply it by the sample size. And that gave me that 250. And that's how I got that. Okay, and then if I have the probability of chocolate, well, that's the same. So I would do the same thing. Chocolate is 0.25 times 1,000. And that gives me 250. And I do that for each one. So like the probability of strawberry was 0.15. And then I do 0.15 times 1,000. And I get 150. Oh, sorry, strawberry was 20%. And butter pecan was 15. So 20% times 1,000 gives me 2,000. Okay, so you would do, or sorry, 200. You would do that for each one and get the expected counts and fill them in your table. Then we're going to write the null and the alternative. So the null and the alternative are slightly different for this type of test. They're always in words. And the null is always that the distribution of counts of blank occurs in a manner consistent with the model provided. And the alternative is the distribution of counts occurs in a manner that's inconsistent with the model provided. So for this problem, I would say the distribution of ice cream flavors is consistent with the model, and the alternative with the distribution of ice cream flavors is inconsistent with the model. And so that's how we'll always write our null and our alternative for the GOF test, which is when we're comparing the observed and the expected. Okay, then we're going to run the test. And if you don't have that command, it is a little bit harder. Okay, so you actually have to find the test statistic kind of by hand. And to make it a little bit easier than having to like do this entire formula by hand where you do like observed minus expected squared divided by expected, we're going to do it in our calculator to help you out. So what we do is the first thing is you need to enter your observed into L1 and your expected into L2. So you're going to go to stat edit, and I already have it in, so you need to pause and put it in. We'll put your observed in L1 and your expected in L2. Okay. After you do that, what you're going to do is you're going to pretty much do this formula in your calculator. How we do that is we're going to do that formula by just doing our list, so we don't have to do it by hand. So we're going to take L1, which is our observed, minus L2, which is my expected, square it, and then divide by L2 because that's my expected. And that's the formula for the chi-squared. So we go up and we highlight L3. You need to put parentheses. You hit second 1 for L1 minus second 2 for L2. close parentheses, square it, and then we always divide by L2 because we're dividing by the expected. Hit enter, and it will fill in that value for each of these values, where it did like 220 minus 250. That's negative 30. It squared that, and then it divided by 250, and you got 3.6. And it does it for all of those values in our table. Okay, so we need the chi-squared value is the sum of that. So to sum that, what you can do is you hit set and quit, get out of there, and then hit stat, or no, second stat. So hit second verse stat, arrow over to math. And then if you go to number 5, it will sum and hit second L3. And it will add up all the L3 values. That's the sum. Okay, and then that's your chi-squared. That's your test statistic. So that's the first thing you have to write down is the chi-squared equals 9.679. And you'll need to, if you're doing it this way, like write that formula down because you don't have a test to run in your calculator. Okay, so we find that. Once we find that, okay, and again, the instructions are in your packet. This gives us the chi-squared value. We then have to find the p-value, right? And so the p-value is the probability under the curve of getting, this is my chi-squared value, chi-squared curve. It should be a little bit more skewed, right? If this is my chi-squared curve, and my chi-squared value is here, the p-value is the probability of getting a value higher than that. So it's probability of getting that value or higher. And so it's very similar to like that normal CDF, but we use chi-squared CDF. And then we do lower bound, which is whatever the chi-squared value is, comma, it doesn't have an upper bound, so we use 6 nines. And then the difference is we put the degrees of freedom, and the degrees of freedom is the number of categories minus 1. So it's always a right tail test. The upper bound is always 6 nines. So what we'll do is we'll do chi-squared CDF. We'll put this test statistic 9.679, comma, 6 nines, or you can use that 1E99, whichever one you preferred. Okay, comma, and then the degrees of freedom. Okay, so if we look, the categories, there's vanilla, chocolate, strawberry, butter pecan, rocky road, other. If we count, there's 1, 2, 3, 4, 5, 6. So the number of categories is 6. So the degrees of freedom is 6 minus 1, is the number of categories minus 1, which is 5. And you have to put that there, 5. So you're going to go to second distribution, where we went for the normal CDF, scroll down to the chi-squared CDF, put this chi-squared value as your lower bound. The 6 nines as your upper bound. And then the degrees of freedom, which is 5. And if you have a really old calculator, you're gonna just have the blinking screen and you'll just type it in like I did here with the commas and hit enter. And then that is your p-value. So what you get from that is your p-value. And so our p-value is 0.08. And then everything else follows from how we do the normal test. So alpha, they said was 0.05. My 0.08 is greater than 0.05, so I fail to reject. And then my conclusion is very similar to what we have done so far. We say, since the p-value is is greater than 0.05, we fail to reject the null hypothesis and conclude there is not, in this case, because we're rejecting enough evidence 4, and we always talk about the alternative. So I'm gonna find my alternative, and the alternative is the distribution of ice cream flavors is inconsistent with the model. And that's what I'm gonna say. It's not necessarily the question from the problem like we did before. It's whatever the alternative is. So it's not enough evidence for the distribution of ice cream flavors is inconsistent with the model. And so that is our alternative. So we'll do similar questions in class, but review this and practice with this, because if you have an older calculator, it's definitely a lot harder to calculate these statistics.